Polynomial long division. Polynomial long division is similar to the process for dividing integers. And we express the result in the form dividend equals divisor multiplied by quotient plus remainder unless otherwise stated. Let's have a look at a couple of examples. Example 1. Find 3x to the power of 4 minus 4x cubed plus 4x minus 8 in brackets divided by x minus 2. Now what you'll notice is that there's no x squared term in the dividend. So we need to include it but with a coefficient of 0. So this will help the long division process. So let's begin. So we start off by taking the leading term of the divisor and we divide it into the leading term of the dividend. So x into 3x to the power of 4 goes 3x cubed times. Then we take the 3x cubed and then we multiply it by the divisor. So 3x cubed multiplied by x is 3x to the power of 4 and 3x cubed multiplied by negative 2 is negative 6x cubed. And notice that we line them up under the first two terms of the dividend. And just like with integer long division, we just subtract one from the other. So 3x to the power of 4 minus 3x to the power of 4 is 0. Negative 4x cubed minus 6x cubed, so that becomes a plus. We get 2x cubed, and then we drop the next term down. So the 0x squared gets dropped down so that it's added on to 2x cubed. And then we repeat the process again. So x into 2x cubed goes 2x squared times 2x squared multiplied by x minus 2 is 2x cubed minus 4x squared. Then we subtract one from the other, so 2x cubed minus 2x cubed is 0. 0x squared minus 4x squared is 4x squared, positive 4x squared. And then we drop the next term, so this 4x gets dropped down so that it's next to the 4x squared, so added on to the 4x squared term there. And then repeat the process again. And so repeating the process multiple times, we end up with a remainder of 16. So we can express this division, or this result, as 3x to the power of 4 minus 4x cubed plus 4x minus 8, so that's the dividend, equals x minus 2, so that's the divisor, multiplied by the quotient, so 3x cubed plus 2x squared plus 4x plus 12, plus a remainder of 16 that's written as a separate term, so added on to this product. So example number 2, so I'll go through that quickly. So it's the same dividend but a different divisor. So we're dividing it by x squared minus 2 instead of x minus 2. So what you'll notice is that with the divisor, I've included the x term because it's not included in the original statement there. Okay? But again, to help the long division process, all the terms need to be present even if they have coefficients of 0. So that will definitely make life a lot easier. So repeat the same process. So x squared into 3x to the power of 4 goes 3x squared times 3x squared multiplied by x squared plus 0x minus 2 is 3x to the power of 4 plus 0x cubed minus 6x squared. So notice that there's 3 terms now instead of 2 in the as opposed to the previous example. Subtract one from the other. So 3x to the power of 4 minus 3x to the power of 4 is 0. Negative 4x cubed minus 0x cubed is negative 4x cubed, and 0x squared minus 6x squared is positive 6x squared, and then we drop the next term down. So notice that the number of terms that we're dealing with needs to be equal to the number of terms in the divisor every time. Okay, so this is the same thing with example number 1. Notice that we always have to have 2 terms to deal with. Okay, in this case here, there are technically 3 terms, even if one of the terms has a coefficient of 0. And then going through this process again, we end up with a quotient of 3x squared minus 4x plus 6 with a remainder of negative 4x plus 4. So we could write this in the form dividend equals divisor multiplied by quotient plus remainder. So 3x to the power of 4 minus 4x cubed plus 4x minus 8 is equal to x squared minus 2 in brackets multiplied by 3x squared minus 4x plus 6 in brackets plus, so notice I've written the remainder separately in its own set of brackets, negative 4x plus 4. So this is in the form px, so we usually, the dividend is designated with a capital Px, so P of x is equal to D of x, so that's usually what we use for the divisor, multiplied by Q of x, so that represents the quotient, plus R of x, which represents the polynomial, which is the remainder polynomial there. Now it's important to note that D of x cannot equal 0, so it's just That's usually the case, but we can't divide by 0 there, so we can't divide by the 0 polynomial. And also the degree of the remainder has to be less than the degree of the divisor. So it doesn't make sense for the remainder to have a higher degree or even an equal degree to the divisor. So what that means is that if that's the case, you haven't completed the long division process to its end. So there's still another step to go if you haven't finished it. Now, just like with the example involving integers, if the remainder is 0 or the 0 polynomial, then what we can say is that d of x, the divisor, or what we call the divisor, is a divisor of p of x. So that means it divides it evenly, leaves no remainders or a remainder of 0. And d of x and q of x, so these two terms, okay, so d of x and q of x, are called factors of p of x. So it's just like with integers, if 20 divided by 4 equals 5, then, with a remainder of 0, then 4 and 5 are considered factors then of 20, since the remainder is 0.